Okay, so first of all, this is actually 12.4, so you could cross that 5 off and put a 4. There's no 12.4 in the notes, I made a mistake, so this is actually 12.4. And this is the multiplication rule for independent events. Pretty straightforward, pretty quick video here. Let's get into it. First of all, students will be able to find probabilities of independent events. Pretty easy stuff, but we got some vocab we got to learn here. First off, a compound event or composite event consists of two or more simple events. That's it. It's just two or more simple events. So when we're asking a probability of two things happening, well, that's a compound event. And we have two different types of compound events. Events A and B are independent events if the probability that A occurs does not affect the probability that B occurs. Does not affect, okay? So that's what makes them independent. They do not affect each other. Okay, and then the other type of compound event is events A and B are dependent. So you got independent and dependent events. And that's if the probability that A occurs in some way changes the probability that B occurs. For example, you got 52 cards in a deck, you pull one out. Well, after you pull one out, if you don't put it back in, now you only have 51 cards. And so that idea is a dependent event. Okay, so let's talk about this. Determine whether the following events are independent or dependent. And I'm just going to put an I or a D. Ready? So one coin is tossed, and then a second coin is tossed. Well, these two coins do not affect each other's outcome, and so these would be independent events. Each student from class is giving presentations. So the teacher puts all their names in a hat and pulls them out one at a time, not replacing their names. Well, whenever she pulls a name out, there's one less name in the hat, and so the odds are constantly changing. So yes, this is a dependent event. All right, Wednesday's lottery numbers and Saturday's lottery numbers. Well, the lottery numbers are totally independent of each other. So we could say those are two independent events. They don't affect each other whatsoever. All right. So let's talk about the probability of two independent events. The probability that two independent events both occur is the product. Remember, product means multiply. That's why I have the little dot there. The product of the probabilities of each independent event. And an easy way to think about these is try to think about what the probability of just one event is first. Before you try thinking about the whole thing, just think about one thing at a time. So for example, what is the probability of flipping a fair coin 3 times and getting tails, heads, then tails? So again, you can make a tree diagram for this. So I'm going to try and zoom in and show you. We want tails, heads, and then tails. Okay, so let's just think about that. Well, on the first stage, remember, we've done this before. You get tails and heads. And the second time, you get tails and heads, right? And the second time, you get tails and heads. And on the third stage, you could get tails and heads here. You could get tails and heads here. You could get tails and heads here. And you could get tails and heads here. Okay. Now, it's going to start to get pretty crazy trying to calculate this out every time. But what's going on here? We want tails, heads, and then tails. Well, automatically, that means, I'm not looking at anything over here. But tails, and then heads, and then tails. Well, there's just one track where that happens. That's 1 out of 8 possibilities, right? Okay, well, what's really happening here is you have a 1 in 2 probability here. You have a 1 in 2 probability here. You have a 1 in 2 probability here. You had a 1 in 2 of flipping tails, then you had a 1 in 2 of flipping heads, and then you had another 1 in 2 of flipping tails again, making this. And when I say 1 and 2, I'm talking about each of that one after that previous event happened, right? So it was 1 and 2 here, 1 and 2 here, 1 and 2 here. Okay. Well, what this rule says is, instead of making a giant tree diagram every time, you could just say, all right, well, the probability of tails, heads, and then tails would have to be the probability of tails times the probability of heads times the probability of tails. As long as these are independent events, that's all you got to do is just multiply those probabilities together. Well, we already know the probability tells us 1 over 2, 1 over 2, 1 over 2. Well, 1 over 2 times itself 3 times. 1 times 1 times 1 is 1, and 2 to the third power, 2 times 2 times 2 is 8. And so this thing is 1 out of 8. Well, we already said that from the tree diagram, but this math may become a lot easier to do than making a giant tree diagram. I mean, what if we're just flipping the coin like 20 times? Obviously, we're going to want some shortcut for that. Okay. Let's see, practice number 2. There's a bag with 4 blue marbles. Actually, maybe I should do this. Maybe make that blue. 4 blue marbles and 3 red marbles. Melanie pulls 1 marble from the bag and then replaces it. Okay, so that makes it going to be an independent event. She then pulls another marble from the bag. What's the probability of pulling a blue marble and then a red marble? All right, I want you to try and figure this one out on your own, and then check back when you're ready to check your work. Okay, so the probability of pulling blue and red is simply the probability of pulling a blue times the probability of pulling a red. So the probability of pulling a blue is 4 out of 7, while the probability of pulling a red is 3 out of 7. So 4 times 3 is 12, 7 times 7 is 49, and boom, the probability of doing these 2 events in that order is 12 out of 49. Pretty cool. All right, that's it for this video, but I'll see you guys on the next one.